Okay, so for this section, we've talked about solving systems and linear equations using graphing. There's two other methods that we can do to solve for systems. In this first one, we're going to talk about substitution. We'll talk about elimination in another video. So we're going to use substitution, and the key for this is when one of the problems already has a variable by itself. And what I mean by that is you'll usually see standard form where there's an x and a y on the same side of the equation. You can see here y is solved already. Y equals this whole thing. So if we have one or both of them where one variable is by itself on one side of the equation, we're going to use this substitution method. Okay, so there's two types of examples. One where only one of them is solved by itself, and one where both of them are already solved. So in this example, you can see y equals this and y equals that. So there's two kind of examples of how we're going to go over that. And then I'm going to go over these, and it's almost easier to see it play out than it is to look at the notes. But the notes are here because these are going to spell it out for you. Your steps, make sure one of the variables is isolated by itself. That tells you you're going to do substitution. So in these they are. Step 2 is substitute the variable in for the other equation. So there's an equation with only one common variable. Solve for that variable mathematically. So you're going to use a lot of algebra in this section. Use the answer from step 3 to put into your other problem, so into this, and then you'll have an answer for x and y. So if you look at this kind of walks you through it with all the steps as well. So step 1, we have this one that's substituted by itself. So what we do is we substitute this. Since y equals this, we put that whole thing, we replace it from the y. And remember, when we substitute, we put it in parentheses. So then what we do here is now we are solving this equation for our variable x. Distribute 3 times 6, 3 times negative 7, we get that. Combine our like terms, that gives us 20. Minus 21 equals 4, then we add 21 to both sides, get 25, divide by 20, and we get our x equals 1.25. So that is basically half of what we need to do, right? Then what we do, now that we have x, we can plug it into this x in the problem to then get our y, right? So if I look at this equation, instead of x, again, I substitute, put it in parentheses, 1.25. You type this right into your calculator, and you'll get your y of 0.5. So there's our two ordered pairs, or our one ordered pair that is a solution to this system. Again, you can type these into Desmos and see where it is, but the point of this lesson is to practice it algebraically, okay? The other method, or the other scenario you're going to see, is when both of them are solved by themselves. Well, if that's the case, then we're just setting them equal to each other. So you can see they're both solved for y here. So negative 4x plus 8 is equal to x plus 7, and then we solve, right? So this would be step 2, solve for that variable. So wherever you want to start, maybe you add 4x first, that gives you 5x, then subtract 7. 8 minus 7 is 1, divide by 5, and you get x equals 0.2. And at that point, you can then put the 0.2 in for either this x or this x. And that's what I did in step 3 over here to show you. So use the answer for step 2 to substitute and solve for the other variable. So I did both. You only need to do one of these, because if I put a 0.2 in for x and type this into my calculator, I get 7.2. And if I put this 0.2 in for x and type that in my calculator, I also get 7.2. So my ordered pair that makes this true would be 0.2 and 7.2. All right, so let's go ahead and go over a couple of these examples. I'm going to do one of the two for each of these, and you can practice the other one. I'll put the answers up here so you can see you can check your own answers. But if we look at this, I see that this y is solved, and I can put it in for this y. So this would be 3x, and instead of y, I'm going to put the x minus 7 here. So plus x minus 7. So that went into there, and I'm going to finish out this equation with 9. All right, and now I solve. Combine my like terms. 3x and x is 4x. Minus 7 equals 9. We need to get x by itself, so I'm going to add the 7 to get rid of it. 4x equals 9 plus 7, which is 16. Then we can divide by 4 to get x by itself. So x equals 4. So there's half of my problem. Now for the other half, I just have to plug this into either this problem or this problem to solve for y. If y is already solved by itself, pick this one, right? So then I just basically have, and we can do this in our head, but you can see y equals my x, which is 4 minus 7. 4 minus 7 would be negative 3. So y equals negative 3. So there's my ordered pair. So you can, at this point you might be exhausted with doing math, so you can either just leave it like that, or you can represent it as your ordered pair 4 comma negative 3. All right, here's another example. Go ahead and pause it and maybe try this on your own. Okay, so now we have to substitute this 2x plus 6 in for this y. Now notice I'm going to have to distribute. So negative 3x plus 2, and then whatever we substitute, put in parentheses. 2x plus 6 equals, and then it equals negative 6. So distributive property, we take this positive 2. Be careful with this sign. If it's a negative, you have to distribute the negative. So I'm going to rewrite this, negative 3x, and then I'm going to distribute my 2 to 2x and my 2 to a positive 6. One of the methods we did use was the box method, which some of you guys might still like. 2x, and 6. So this will be 4x. This will be a positive 12. So positive 4x, positive 12 equals negative 6. So the only method I did, or only step I did, was distribute here. Then I can combine like terms. Negative 3 plus 4 is going to be 1x. So you can either put 1x or just x. Plus 12 equals negative 6. Subtract 12 to get x by itself. So x equals negative 6 minus 12 is negative 18. So there's half of my answer. Again, don't get exhausted at this point because you're almost done. You have to use one of these two. Y is already solved. So go ahead and use this equation. So y equals 2 parentheses negative 18 plus 6. And at this point, if you have your calculator handy, you just type that right into your calculator. So you can see I brought the calculator up here. So 2 parentheses negative 18 and then plus 6. That gives me negative 30. So my y equals negative 30. So there's my two answers. All right. And again, we can use that as an ordered pair. Negative 18 comma negative 30. Okay, so now here we have two examples where we set them equal to each other. So these steps are going to be similar. So I have this y and this y already solved, so I basically set these equal to each other. 3x minus 10 equals 2x minus 5. So we're replacing the y with that. Now I have to solve for this. So I could maybe subtract 3x if I want. I can add 10 depending on where you want to start. But let's, you see, usually people see this negative, so, oh, I got to add 10. That's usually the indicator of where students want to start. So I'll rewrite this. 3x equals 2x. Negative 5 plus 10 will be plus 5. Now I got to get this x term over here. So subtract 2x from both sides. So that would be x, 1x equals 5. So there's my value for x. Pick either one of these two, it doesn't matter. Maybe we'll pick the second one. So then I can substitute 5 in for x. Y equals 2 times 5 minus 5. So again, you can type this right into your calculator. 2 times 5 is 10. Minus 5 is 5. So y equals 5. There's our ordered pair of where they meet. 5 comma 5. So a cool thing about this, like if I check my graphing calculator, and this is a good way to check your answers. Let's say I put these two equations in, where they intersect should be at 5, 5. So y equals 3x minus 10. Y equals 3x minus 10. And then y equals 2x minus 5. And I see where they connect, 5, 5. So that's a way to check your answers. Don't rely on this because I want to make sure you can do it algebraically, but of course, type them in to make sure if you're getting the answers right. So let's go ahead and try this last one. Again, they're both already solved for y, so we set them equal to each other. So I can say negative 2x plus 1 equals x minus 5. Now we have to do our algebra. Maybe this stands out to you, so let's get rid of that. Add 2x to both sides. So that leaves me with 1 equals 3x. 1x plus 2x is 3x minus 5. Now I have x is already here, constant, constant. So let's get rid of this 5 by adding 5. 6 equals 3x. Divide by 3, we're almost done. X equals 6 divided by 3 is 2. So there's half of my answer. Now I have to solve for y, so let's try this one. So I will put x in for this. So let's do y equals 2 minus 5. 2 minus 5 is negative 3. And there's my ordered pair solution, 2 comma negative 3.